Hello everyone, today I'll be going over GCSE Physics and I'll be focusing on latent heat of fusion and vaporization. So today we'll look at specific latent heat and see how to use this in calculations. So as we heat up a substance, the particles gain energy in their kinetic energy store. This is when there's an increase in internal energy. Temperature is just a measure of average internal energy for all the particles in a substance. So as we heat objects up, their internal energy of the particles is increasing, so the object's temperature increases as well. So the key point is that there's only one exception. This is that when there's a change of state. So you can see that there's not a straight line as you would have expected. This is because when an object is changing state, so maybe a melting or boiling point, the energy that we are providing is being used to weaken the forces holding the particles together rather than increasing the particles' internal energy. And remember, the temperature is just the average internal energy of the particles. So at the stage of melting and boiling of a substance, the overall temperature won't change until all the substance has changed state. The same principle applies if we look at a similar graph for cooling a substance. In this case, it involves the formation of new bonds between particles, which releases energy so it counteracts the cooling. This is what keeps the temperature constant during a change of state. Now, the exact amount of energy is required to change the state of a substance while the temperature stays the same, and we know this as latent heat. This depends upon the type of substance and the amount of substance. We use the term specific latent heat, which we can define as the energy required to change 1 kilogram of a particular substance from one state to another without changing its temperature. So there are two types of latent heat. One being specific latent heat or vaporization, which we can say is the energy change when a substance changes between a liquid or gas, so either evaporates or condenses. And there's another called specific latent heat of fusion, and this is the energy change when a substance changes between a solid or liquid, so either melts or freezes. To see how this all works, let's imagine that we have 1 kilogram of water and that we heated it all the way from -50 degrees where it was a solid ice to 150 degrees where it's water vapor. So as we heat 1 kilogram of ice, its particles all gain internal energy, so its temperature increases. However, once we reach 0 degrees Celsius, the ice starts to melt because all the heat energy that we are supplying is being used to break the forces between the particles, and the overall temperature stays the same. The energy required for this state is the specific latent heat of fusion, and in this case of water, this is 334,000 joules per kilogram. Once this much energy is being provided and the ice has been melted into liquid water, then the temperature will continue to increase all the way to 100 degrees Celsius, where the process happens again. This time, energy is required is the specific latent heat of vaporization. So this is 2,260,000 joules per kilogram. And once all the water has been boiled into water vapor, its temperature continues to increase like normal. You don't need to learn these figures, as you will be given this in an exam. So as we said before, if we were to cool the water, the same concept would apply. But the amount of energy that we mentioned for the specific latent heat of vaporization and the specific heat of vaporization would be the amount of energy released rather than the amount of energy required at each stage. Lastly, we need to look at equations. So this says that the energy that is required or released is equal to the mass of a substance in kilograms times the specific latent heat in joules per kilogram. You can also use this diagram, which also helps. So a typical question would be how much energy is required to completely boil 2.5 kilograms of water at 100 degrees Celsius. So as we are boiling the water, we are going to need the latent heat of vaporization in value. So as this is the one that refers to boiling, so we just do 2.5 kilograms multiplied by 2,260,000 joules per kilogram, and this you get 5,650,000 joules, but into kilojoules you get 5,650. Thank you everyone for listening to my video. Bye.